Welcome to today's or this month's AGU AGI Heads and Chairs webinar. I'm Christopher Keene, Director of Geoscience Profession and Higher Education at AGI, and I have Pranoti Asher, who's Assistant Director of Grants and Education Programs at AGU, as also on the line and helping host this meeting today. Just want to take advantage of this opportunity to remind everyone that this year, this calendar year, where all the Heads and Chairs webinars are focused on different components that were addressed in the Vision and Change in the Geosciences, the Future Undergraduate Geoscience Report. That is freely available at the URL that's on the screen, americangeosciences.org/change. If you are a department chair, the mailing of a physical copy to all the departments should be going out here hopefully within the next week. They're supposed to be delivered Monday or Tuesday, and then we will be mailing them out from then. In today's webinar is looking at implementing curricular reform. This is obviously a huge challenge, and one that within the Vision and Change effort saw all kinds of wins and challenges, and we're really pleased to have James Kubicki from the University of Texas El Paso and his colleague Hugo Gutierrez, who have done a lot of work in implementing curricular reform, and I think we'll be able to shed some real light on the issue for us. So, Jim, if you want to go ahead and share your slides. Perfect.
Okay, so I was asked to give a quick overview of our experience of trying to update our curriculum here. So I'm going to do that, and then Hugo is going to talk about a specific course that he developed that I think is a great example of what we're trying to do, and I think a useful trend in geoscience education. I had some good fortune as we were trying to do this. In spring of 2015, I had just interviewed for this position, and this was one of the slides from my job talk. And I had been a professor for about 17 years, and I was thinking about becoming a chair, and it made me really rethink what we were doing, the way we were delivering education. And I started to realize we're probably doing things very wrong for our students. And so I started to pose some of these questions about educating students about career opportunities and giving them the skills that they really needed to thrive. Another fortunate happenstance is that external organizations like AGI were doing research on this at the same time. And I love this diagram because it quickly shows how where we have circles in brown, where we're spending more time developing skills that are important, but maybe not as important as we think they are in our academic program. And then wherever you have blue here, larger than the brown circle, that's where we're not spending enough time. And that's particularly important here in these non-technical skills. And so this really shows we needed to revise our curriculum, and we needed to inform students that skills are really the key things that employers are looking for. The way we deliver most classes by content, I don't think students were really picking up on that. And so that's one thing we wanted to emphasize to students, to recognize what skills they were learning and to advertise that as they went out and looked for jobs. And the other nice thing for me was in January of 2016, so I had only been a department chair for one semester, we had this summit in Austin, and there I was able to get answers to a lot of the questions I was asking myself and our faculty about what we were doing, and also to get data and support to convince any potential skeptics in our faculty about the fact that we needed to make change and what type of change we needed. So this was just really one of the greatest few days I've ever spent. I learned so much here from other chairs that had much more experience than me, and was able to bring that back to UTEP. Shortly thereafter, we had a faculty retreat, and we wanted to talk about revising our curriculum. And I sort of blend our graduate and undergraduate curriculum together because the skills and a lot of the things we do are very similar. And actually, a lot of our undergraduate students stay for graduate school at UTEP anyway. And at the time, UTEP was developing this student engagement program called the EDGE. And so we folded what we were doing in our curriculum revisions into this EDGE program. And we sort of used this MOOC matrix to figure out which classes were giving students which skills. We realized we were doing great in a lot of areas, that those skills were being emphasized to students in multiple classes. Other areas such as entrepreneurship and social responsibility, maybe not so much. And so we've hired new faculty in economic geology to help bulk up our entrepreneurship in our program. And we've been bringing in more outside speakers talking about social responsibility issues in our seminar series. But the overall goal of this exercise was to make our curriculum more cohesive, to make sure that everybody knew what everybody else was teaching, so that as a student went through, they would see this as a whole, not little bits and chunks all separated into individual courses. We agreed on the major skills that we wanted our students to get. We wanted to advertise to them that these were really what they were getting out of our education, as well as fundamental knowledge. But these skill sets were what they wanted to advertise, because then they could use that to promote themselves as they went to look for jobs in a wider variety of careers than they might think. And so once we agreed on these skill sets, we started to inform students that that's what they should be getting. That's what employers were looking for. And one thing we did was we gave them out templates for resumes and told them explicitly, these are the kind of things that you should be emphasizing. Make sure you're getting these in your classes and have evidence for how you're developing these skills as you go, because this is what employers are looking for. And so I like this idea because they were looking forward to after graduation, not just, oh, what's the next class I need to take to get to graduation. Yeah. One thing that we do is we pair our courses so that they're taught together. This allows us to pair our labs, so it gives us more time to go out in the field. Of course, El Paso is an excellent geological laboratory. If you ever need some place to take students, the region around here is fantastic for all kinds of geological sites. And so we're very lucky because we can take students out half an hour, a short drive from campus, and see geology in action. We started this, Diane Dozier notably started Intro to Physical Geology lab section for majors. That was a team-based research project, so students started to get involved in research right from the beginning, and also feel like they were more of a cohort. That's somewhat of a problem at our campus because it's a commuter campus. Most of our students work, and so they're not hanging around and developing camaraderie all the time. But through courses like this, they got to know each other better and feel like they had a family or a team to get through with. And Diane and Rob Warbar from El Paso Community College actually started to do this before they reach UTEP, because a lot of our students come from EPCC. And so they started a program for community college students to help them transition to UTEP and get involved in research. Another thing we're doing is we've all created these one-slide intros for students taking our classes, which can be used in intro classes or other classes, to let students know who we are, because we realize they're not all meeting all of our faculty, and the kinds of exciting things that we're doing. They may not have a good impression of what geologists really do. And so we're trying to get students to know us in general as people and as scientists throughout our program. This is a recent hire. Hernan Moreno just started this year is doing some cool work, and we thought, well, we could really attract some students who are interested in high-tech things like doing remote sensing with drones and that, and GIS that they may not realize was in our department. And we also have ensured that we get students out into a lot of internships. This is the main game changer. Here is an example from Angela Trejo, where she went to Woods Hole a summer or two ago and had a great experience. And so we used these experiences, and then we pass this on year after year, from student to student to get them out of El Paso, which sometimes is problematic because there's a strong family culture here that people are somewhat reluctant to leave their families sometimes. But when we get them to do this, it is a game changer in terms of their attitude towards their education. And I'm going to switch over to Hugo here in just a second. I want to introduce Hugo. He's hiding in here somewhere, unless, oh, there you are. Yeah, but he created this very innovative course with computer science here, and I think this will show a great example of what we're trying to do throughout our undergraduate and graduate curriculum. So with that, I'll turn it over to Hugo, and I'll just tell me next slide, and I'll change the slides as necessary. Okay.
So yes, this example, it's a class that I taught together with a colleague in computer science. And you watch a transdisciplinary course where we had both undergraduate and graduate students working collaboratively throughout the semester, developing web-based applications for solving some, societal, environmental issues with societal relevance in our region. And the students in this class worked in teams, and they learned to communicate and to integrate, the two knowledge domains, the computer science and the earth science domain, to come up with, prototypes of web-based applications that can help to solve some environmental issues. This was a very nice example of a pilot class that we are gonna try to do again, and which we are trying to improve upon. If we can go to the next slide, please. I also want to talk to you about a class that I taught a couple of years ago. It was an ecohydrology class that was a team based on teamworks and experiential learning. And I want to talk to you about this class because in this course I challenged myself to challenge the notion that in order for us to be able to get students to work on improving their computer literacy and data analysis skills, they need to have already some sort of background. And as you would see, this was a very diverse class in terms of the kind of students that were there. If we can go to the next slide, please. So the class was designed to address all of these different technical and non-technical skills that had been recommended at this meeting that Jim was talking about at UT Austin, in which there was a realization that we need to give students more data analysis with real data sets. They need to be able to solve three-dimensional and four-dimensional problems with non-unique answers. They need to improve their quantitative skills and their math competencies in things like statistics, probability, uncertainty analysis. Obviously, we need to teach them more on how to do computer programming and modeling. But at the same time, we also need to allow them to develop these non-technical skills that are very important. For example, teamwork, project management, communication and interpersonal skills, leadership, professionalism, things that are that allows them to address, societal relevant issues, and also to give them some sort of global perspective. If we can go to the next slide. So I use this class as a vehicle to try to address all of these different points. And the way I tried to do this was to make the class based heavily on a project that the students would develop throughout the semester. So so for that, I basically assembled teams of 2 students, and for each, and then we will develop a project, each team. And for each one of these projects, there would be a data collection, processing, analysis, interpretation exercise, and a full report will be developed and handed out at the end of the semester, following, the format of a professional publication or a professional report with all of the different components that they need to have. If we can go to the next slide, please. This was the structure of the group. As you can see from that pie chart, I have 7 undergraduates and 7 graduate students, and with all of them varying levels in their programs. We had sophomores, juniors, seniors, and graduate students doing certificates, master thesis, and PhD. So if we can go to the next slide. As you can imagine, this gave us, or this gave me, a very uneven level of background in terms of the different skills that they have attained at the time, computer skills and math skills. And so this is where a big challenge, or the most challenging part was for me as an instructor. If we can go to the next slide. This is what I found while I started, trying to teach this class. Most students have difficulties digesting, the concept of algorithm. They have difficulties learning a new language, learning the new syntaxes, the coding environment, translating simple commands into computer code. Many of them, show paralysis in front of the coding environment. They were completely unfamiliar with matrix operations. They had difficulties conceptualizing, this matrix-based analysis. And as a result, they also have difficulties relating the concept of the spatial and temporal analysis. So if we can go to the next slide. So what I did is that I basically split the class in 2 parts. The first part was what I call participative lecturing, in which it was very conceptual based. I used that portion of the class to introduce the main ideas and the theoretical background of the topics. At the same time, I would allow the students to start exploring research ideas and to start building hypotheses and interacting among themselves, having discussions on these issues. And by the second part, I focused mostly on the quantitative portion of the class. So this was building their skills, sort of to try to level them, all of them. And so we did a lot of data exploration, fetching and quality control of data sets, doing a little bit of programming, introducing algorithm development and implementation, doing some spatial and temporal analysis of large raster data sets. And if we can go to the next one. So the way I try to do this is, we work very heavily on MATLAB and introducing this new coding language for many of them. We had lots of practical lessons, lots of drills on math operations, exercises of syntaxes, the definition of variables, introducing, matrices and their operations. I place a big emphasis on building 3-dimensional matrices for 4-dimensional analysis, and we look a lot into different kinds of data sources, quality control, consideration of these data sets, using basic statistical concepts. And if we go to the next slide. However, I realized at the middle of the class that if we were gonna be able to succeed in doing this, we had to change gears. So what I did is that I told the students, you know what, you guys are in charge now. This part of the class is going to be completely driven by you. And what I did is that I used the 2 sessions of the week that I had in the class for the teams to present their progress. And so every class, the 3 or 4 teams would present their progress, and they would highlight, their new findings, the methods that they were using, and the challenges that they were having. And it turned into a completely interactive session. The students would get real-time feedback from myself, but also from their peers, because many of them were having the same sort of issues. And one thing I noticed is that, the attentions of the students during the class was very much improved. We will have these very lively discussions, and they were driven by their challenges and their findings. The students were very much engaged and very participative. So much so that I noticed, a dramatic increase in the attendance of the students to office hours seeking for help. So every single day of the week, I would have groups of students waiting for me. And that was all of the second part of the semester. So they were really, really very much engaged. So if we can go to the next slide. This is just to give you a flavor of the kind of topics that the students were working on, and the geographic distributions of the areas where they had their projects. And if we can go to the next slide. These are the results from my perspective. 70% of the class receive an A. They really did outstanding job. 30% receive a B. As you can imagine, the final projects varied in the level of quality, and all except but one, exceeded my own expectations. Most of these projects attain thesis chapter quality, both in terms of the format, but also in the quality of the research and the information that they generated. And all of the projects had reports included an appendix with the code scripts that they generated throughout the semester. To give you an idea, the average length of the script was about 700 lines of code. And obviously, they all varied in the level of complexity. But even one student provided coding scripts in both MATLAB and Google Earth Engine. If we can go to the next slide, you will see, some samples of their reports, and so you can see the quality of the analysis and the graphics that they were able to produce, and it was quite impressive. If we can go to the next slide, I'll show you. We revisited at the end of the class the objectives for these recommended skills. And we saw that we pretty much addressed all of them except but one, the field skills, because, we didn't go to the field in this class. We did most of the work in the lab doing remote sensing, basically, and data analysis. But, we were able to address all of these different aspects through these projects. If we go to the next slide, you can see what the students thought about the class. One of them said, I enjoy taking this course. I feel my software and technical skills improve. However, they thought that, they would have benefit if there was a lab involved with the class. So they were asking for more time. And another student said, the idea of this class was really cool, but it really needed a lab, all in caps. So, basically the students were willing to spend more time on it and with the instructor. And, one of the challenges is that for something like this to happen, the instructor needs to be also very much engaged, very heavily engaged. And you can see, from the evaluation that I got, where in the question the instructor was available to students either electronically or in person, you could see that most of them agreed, because I was really available to them. And it took a lot of time from an effort from me as well. So if we can go to the next slide. So yeah, bottom line, apparently that class needs a lab. This is another thing that we are doing in the hydroscience curriculum for one of the programs that we have in our department. We are developing these new online tools for delivery of experiential-based learning. We're doing this using this platform that's called HydroLearn, in which I had the opportunity to work with other colleagues from other universities to develop these learning modules that are completely online and are completely interactive. And if we can go to the next slide, you'll see what I mean by that. So in this platform, the students, work on real life cases with real data in open-ended problems that would challenge them to develop their critical thinking and decision-making skills. At the same time that they, acquire new knowledge and new tools. So these are, some of the examples of the kind of things that we're doing in the department. I think that would be it for me.
Okay, thanks, Hugo. That was a great job. So in the interest of time, I'm not going to go over all these questions and answers. These are questions that Sharon Mosher had asked me a while back about progress. I just want to really emphasize one thing, and it's a major thing, and it relates to what Hugo was just talking about. When I came on as chair, I started talking to our alumni, and I asked them, well, what's the best thing that we can do for our students to make them more employable? And they said, well, make them think more like engineers. We don't want them to be engineers. They can still be geoscientists, but they need to be able to think like engineers because they need more and more to work with engineers. And then I asked them, well, you have a lot of up and downs, especially in the oil and gas industry here in Texas. So what makes an employee less likely to be let go during a downturn? And they said it was programming skills, because those people could be repurposed. And I realized that that's true for the oil and gas industry, but it's true for careers in general. Those skill sets that are developed are useful in all kinds of different occupations. And so the challenge was to get our students to be more quantitative, more computational and mathematical. And I think that's a challenge in general in geosciences, because I think a lot of students who are attracted to geosciences are less quantitative, quite frankly. Many sciences, if they're really quantitative, they go into physics or chemistry. A lot of our students, they like hiking around and understanding the geology and that. And that's a very, different kind of person. And so to encourage them to get those quantitative skills, I think what Hugo is doing and putting it in context of solving socially relevant problems, they can see that and say, okay, well, it's worthwhile now to learn to program in MATLAB and to up my math skills and everything, because I have this goal that I want to reach, and this is a means to getting to it, rather than just something as a barrier in the way, oh, I've got to take calculus and differential equations and linear algebra and programming and all those sorts of things. So I hope this is a way to present a carrot to students that will motivate them to get the skills that they need to be successful in their career and have an impact on society. I'm going to skip over these last two slides. Basically, I can share these slides with everyone if they like, if they want to see any of these, this text. But with that, I'll stop there, and I'll thank you for your attention. And if we have any time for questions, and Hugo and I will try to answer them.
Thank you very much. Great presentation. Fascinating set of efforts that you guys are doing. Question, I'm going to take the lead here. Moderator prerogative. For both of you, did the pandemic, did basically having to start moving and working more remotely? So, Jim, from a department chair standpoint, did you see that forcing maybe some of your faculty that weren't as engaged in transforming their teaching to move some things forward?
No, actually, I was surprised, because as we did that, a lot of departments around here had an issue with it, but I kept asking our faculty. I was worried because nobody was complaining about it. I kept asking them, is anything wrong? What's going on? But they all seemed to transition. And the hardest thing, I think, was field camp. But Jose Hurtado last spring taught field camp remotely, a very innovative way. And he presented that at GSA, where they were kind of doing it like you were on a remote planet or something. If you were going to be guiding the Mars rover or Perseverance or something, but they were doing that here at a local field site, and then the students were guiding that field data collection remotely. So that actually, it seemed to be, we learned from this. It ended up being a positive. And so I felt very, very lucky that way as a chair, that I didn't have a lot of people coming to me and throwing their hands up in the air saying, oh, we don't know how to do this. They all seem to enjoy actually that challenge.
And so, Hugo, for you with your students and things, as folks sort of had a transition, you were definitely already engaging them in some of these kinds of efforts. Did the students' attitudes change, do you feel, towards the kind of work that you were presenting here, like, with your hydro modeling and everything?
Sure. I think they have. I think the students are more willing to do more of these computational things. They are now realizing that it's these are very useful skills, and once you're able to break with them that stage fear when they see these computer codes and and they see that it's not so complicated. Once they're able to start reading in between the lines, they become very much engaged. The part that I find most difficult, it's engaging with them, because you don't have that face-to-face interaction. And I mean, the one thing that I will show you that you will see very quickly is, we're still learning on how to do, what we used to do face-to-face on the computer. For example, when I have to show them, an algorithm and a series of equations and what the equations are and, what the graphics would look like, I still have a little bit of a hard time doing it in the computer. So I have that whiteboard right there that I basically pull all the way here, and then I do it like that. But that's probably the most difficult part. Substituting that face-to-face interaction, it is still quite difficult.
Yeah, that's great. So for everybody in the audience, if you have questions for our presenters, or you want to pose questions to the entire audience, that's fine too. It's a discussion. Feel free. Probably the easiest thing is you can just use the raise hand function, or at this point, if you just would like to unmute, happy to facilitate questions.
Hugo, I'm going to ask you a question, if that's okay, while we're waiting for questions to come up. You mentioned that the students worked in pairs, for your data science course. How did you decide those pairs? Did you do one graduate student with an undergrad, or did they self-select? I'm just curious if you.
No, that's an excellent question, because I had, obviously I faced that question myself. So I thought at the beginning that the thing that made most sense was to pair a grad student with an undergrad, hoping that, the grad student, because, he would be more experienced in doing some of these things, would help to, raise the level of the undergraduates. And that's exactly what I did. I was lucky enough to have half and half, However, one thing I did find out is that not necessarily the grad student was the one, who knew more, or who was, more skillful in the computer part. There were some undergrads that were even much better than the grad students. And to me, what I learned from that is that, it is wrong to make assumptions based on the level of the student. Some sophomores can perform perfectly well at the graduate level, if given the chance and the right instruction.
Great. So Nancy, you have your hand raised. Feel free to unmute.
Hello. I also attended the workshop at UT Austin and also found it fantastic. So this is a question for Jim and anyone else out there. I brought those ideas of how important the non-technical skills are back to our faculty and tried to get them to understand that maybe we should concentrate on teaching those as much as the content, because those are going to, like you said, those are the things that are going to give them longevity in the workplace. And I met significant skepticism and pushback on that. Like, you want me to spend time teaching them to write and program when I should be teaching them, whatever it is, geochemistry, structure, blah, blah, blah. So I'm just wondering if there are ideas out there in the audience of ways to help faculty really understand that, because we haven't experienced a normal workplace, right? We're all doing the same things pretty much that we did when we got our PhDs. And so what strategies out there? You mentioned a few, but there might be other people. Thanks.
Well, I would just say two things. One, I relied on our alumni who are active in the department, especially our successful alumni, to communicate to our faculty that this is what employers were looking for. But also we were looking for ways not to take away from anything that we were doing, but to try and incorporate some of these skills or emphasize some of these skills in what they were teaching them. Because I understand that, oh, I want to give the student this body of knowledge, but can you do it in such a way through an exercise that also develops some of these other skills?
Does anyone in the audience want to chime in, or any other questions? So Rudy, you have your hand raised.
Yes, I have a question for Jim, and I was wondering, in your, what you might call your curriculum reform, did you discontinue a lot of old courses and quote, invent a bunch of new ones, or did you sort of just modify the existing ones? What would you say in general?
It was more the latter, modifying the existing one for our core courses. We have developed some new courses because one thing, we have been hiring a lot of people in the past few years and changing some of the emphasis in our department. But the core courses were sort of restricted by the UT system anyway, and so it was more just revising them. And I think the big barrier was that everybody had started to teach a course and say, oh, this is my course. We were in this discussion, somebody said, oh, that's Phil's course. And then somebody said, no, it's not Phil's course, it's all our courses, really. We're all sort of working this, and we want to have some cohesiveness to that curricular structure, rather than everybody teaching things separately. And people really bought into that. They could see the sense of that. And I try to tell people, make sure you ask other people in the department to help you with your course. They may have some specific knowledge in geophysics or hydrology that could help you make your course better. And so we try to work on our courses together now rather than individually.
Great, thanks.
So, another question, you talked about how you engage your alumni and the companies that they work for, and they sort of told you what they're looking for. Did any of them step up, or did you engage them in a longer conversation or collaboration to, data or guest talks or anything like that to sort of bring that messaging also back straight to the students to get them to understand what the expectations are?
We do that in a couple of ways. One, we do that through seminars. Another, we have 2 times a year where alumni are visiting for the College of Science Advisory Board, and then we'll have roundtables to discuss with them. And as I engage with alumni and ask them for their input, well, recently we had an alumni, he's retiring from the oil and gas business, and he's got a lot of cores and things like that. He wants to donate those and help us incorporate that into our sedimentology class. So it's kind of an ongoing project. But yeah, a lot of times we try to get them to meet with small groups of students to mentor them.
Okay. Kathy, you have your hand up.
Yeah, hi. I too attended at least one of these on the ground kind of programs for department chairs, and I've been slowly working with my department to make some progress in this regard. And the vision and change document that's been released, because it's on paper, it's seeming to be a useful tool now for us. And I just wondered if anyone here, including presenters, would have any advice about if you could do it over again, whatever you've done, what would you not do this time around? So I'm trying to avoid the traps and barriers and things that can slow you down when it's possible to avoid those things. And I'm specifically talking about reviewing our curriculum, doing a curriculum map, using the vision and change skills and competencies as a way to create that map, and then figure out how to sort of tighten up our curricula in marine sciences, geosciences, and environmental sciences, decide if we should swap out some courses, combine some courses, etc.
Anyone have any comments on pitfalls and challenges? I know I know within the Vision and Change, some of those case studies and in Appendix C, people did express, but obviously it's always challenging. Folks hesitate to name their challenges like that.
I can respond if no one else wants to chime in. So I would just say, I was lucky that I was a new chair and I was coming from outside, and so I was in my honeymoon period. If I were going to do it now, after having been a chair for a while, I would probably invite a couple of outside people in to do presentations on this, because the faculty is probably more willing to listen to somebody coming from the outside as more of an expert. And then you can sit there and say, oh yes, that's a great idea, when really it's what you wanted to convince people of in the first place.
Nancy?
Well, I can't tell you the best way to do things, but I can tell you the mistake I made, which was saying, hey, I went to this great workshop and this is a really important issue. But faculty are working very hard at their research and their teaching, and they've got their classes kind of honed down to something that's very effective. It delivers a good content, but it doesn't take as much of their time as it used to. And so I did not give them a carrot. I just said, hey, we really need to do this for the students. And so I think figuring out ways to say, this, I don't know, somehow giving them, making it something that's really good. I think I like Jim's idea of having it come from the outside, maybe somehow talking about how much better off our students will be. And so we'll have these great students out there, and then they will recruit great graduate students for us, so there'll be a big payoff. But I did not give a positive carrot, and now it's that much harder for me to try to implement, because I thought they would see the reason in it. But, they're really busy people and didn't want something else on their plate.
Well, I can say something from my very limited experience. Is when I came to the department, I was basically the first pure hydrologist, if you want to say it that way, that was hired by the department in some time, and there were other colleagues that were doing some water-related research. But now we are more people, and we are trying to grow this hydroscience, program within our department that didn't exist, and that has given us the opportunity to address most of these issues, not necessarily because we wanted to, but because that's where the field is pushing us, and hydrology is a very quantitative science. So, and I see that, for us, while we are trying to develop this program and to grow it, it has been a little bit perhaps easier than other programs that have been established a long time ago that have a different sort of inertia. So relatively speaking, that has given us an easier time to implement these sort of new things. So I guess that's what I can contribute.
Thank you.
So in our last couple of minutes here, any other questions or comments or from the audience? Bill, have your hand up.
Yes, real quick, I would just add, one way to get buy-in is by holding up your successes from one area to another. For example, we participate in an institutional development level NIH grant, and every summer we have 10 to 15 students doing almost exactly a type of project you explained here. And every Friday, those students come to a breakfast where they learned the non-technical aspects, how to shake your hand, how to do a 3-minute elevator talk or a 30-second elevator talk, how to do these kinds of things, how to shave properly, how to wear deodorant, all these things. But we have data that shows their go-on rate increases, their success rate increases, and we can then hold that up to all the other STEM departments and say, if you incorporate this just in your classes once a month, once a week, you'll see improved success. So hold up your successes to your colleagues.
Very good. We have time for one more question, if anyone has something. If not, then just want to thank both Jim and Hugo for terrific presentation, helping lead this conversation. Pranoti, do you want to chime in?
Thanks for having us. Appreciate it.
Sure, thanks. So let me also echo my thanks to you both, Jim and Hugo. It was really, really enlightening to hear what you've done in your department, and hopefully this conversation will encourage others to try similar courses or other things on their own campus. So if you have any questions that you think about, but you didn't get a chance to ask them today, just feel free to email me at pasher@agu.org. I'll be happy to share them with our presenters. And we all obviously have, additional webinars that will be coming up in the next month, later in April and then in May. So feel free to join those. And of course, if you're a department head and you'd like to join the Heads and Chairs community, you're welcome to write to me as well. And if there was another slide, I'd be happy to talk about that. You can look at any recordings of previous webinars that you have missed on this webpage as well. So thank you very much for your participation and hope to see you next month.